so we're going to just get started on complex numbers. This should be a review from things you learned in Algebra 2, but this is lesson 2.4, day 1, complex numbers. And when we introduce the complex number system, we start talking about imaginary numbers. So up until this point this year, we have only had real numbers that we're dealing with. Today, we're going to start talking about the imaginary numbers. So when we think about imaginary numbers, hopefully, the first thing that pops in your mind is I. So try to remember what I equals. I is the square root of -1. So what does that make I squared equal? So I squared is just -1. All right. So one thing you are going to need to be able to do is find the square root of numbers like -25. So because there's an because there's a negative under the square root, it's going to be imaginary. We'll have an I. And the square root of 25 is just 5. So the square root of -25 is just 5i. Okay. And then also some numbers that aren't perfect squares under there. So like the square root of -20. All right. So because there's a negative, I would do something that I call this kind of gross. Like pull out an I and then simplify the square root of 20. So the square root of 20 simplifies to 2 square root of 5. So this is actually going to be 2i square root of 5. Now, in a lot of cases, this book will put the I at the end. And that's fine. Just you do not put the I under the root. All right. And then with the I squared, you'll have things like 3i squared. And anytime your I has a power, it is not simplified. So 3i squared is the same thing as 3 times -1, or just -3. Right? Or if we have -5i squared, that's the same thing as -5 times -1, or just 5. So an I squared always changes the sign of the number in front of it and then basically drops off because it's multiplying by -1. All right, so we need to know the standard form of a complex number. So the standard form of a complex number is the form a plus bi, where a is called the real part and bi is called the imaginary part. So you can write every number in the world, real and imaginary, in a standard form of a complex number. So for all the real numbers, there was no imaginary parts, like the coefficient b was 0. And so when there is both a real and an imaginary part, then you write the real part first and the imaginary part second. So just try to keep that straight in your head. The real part first and the imaginary part second. All right, so for example 1, we're going to perform the indicated operation. All right, so our first indicated operation is subtraction. So we have 2 minus the square root of -27. All right, I cannot subtract those. What I can do is simplify the square root of -27. So I would, because it's a negative under the square root, pull out an I and make it positive 27 underneath the square root. And then I would simplify the square root of 27. So we've practiced this before. I'll do it slow on this one, but 9 goes into 27. 9's a perfect square, divides into 27 3 times. So then that's going to end up being 3i squared of 3. Or don't be surprised if you see it with the I at the very end. I don't care how you write it, honestly. They're both right. But like I said, a lot of times in this book in particular, they'll do the whole number in front, the I at the end. So in this one, the real part is 2. The imaginary part is minus or negative 3 square root of 3i. So this one is in standard form. All right, let's look at B. For B, we have the quantity 7 plus I plus the quantity 3 minus 4i. So we're adding two complex numbers. This is not hard. All we do is add their real parts, which is going to give you 10, and then add their imaginary parts, which is going to be negative 3i, and that's your answer. That is in standard form. Real part first, imaginary part second. All right, and then for C, we have the quantity 1 plus I times the quantity 3 minus 2i. Okay, so we are going to do the double distributive. So we'll start off and we're going to distribute 1. And then we'll distribute I. Okay. And then don't forget that anytime you have a power on I, it is not simplified. So what I'm going to do is go ahead and combine my like terms in the middle there. That's I. So negative 2i plus 3i is plus I. And then minus 2i squared is really plus 2. And that goes back to what we talked about at the very beginning. So when you have an I squared, it's going to change the sign of the number in front of it and then drop off. So that's what I did. And then I want to combine my real parts. And don't forget that the real part goes first. So my real part is 5. The imaginary part goes second. All right. And then the last thing we're going to talk about today is complex conjugates. Okay. So complex conjugates are numbers like a plus bi and a minus bi. So complex conjugates are going to have the same real part but they are going to have opposite imaginary parts. Okay. And something kind of magical happens when we multiply complex conjugates, and I'll show you what I'm talking about. So that's what we're going to do on example 2. We're going to multiply each number by its conjugate. All right, so on A, our original number is negative 1 minus the square root of 5i. Alright, so before we can multiply by the conjugate, we have to find the conjugate. So its conjugate is going to have the same real part, so still negative 1, but then opposite imaginary, so plus the square root of 5i. Okay, so let's multiply these together. Now, we talked about this before, even though we haven't really talked about conjugates. I'm pretty sure I've said that word, and maybe you remembered it from last year. I'm not really sure if you guys talk about conjugates in Algebra 2. But anyway, this is like when before we were multiplying something like x plus 2 and x minus 2. We knew that the outside and inside would cancel, so we could do a shortcut multiplication. Same thing here. Because they're conjugates, we don't have to multiply it all out like we did on the previous problem, because the outside and inside will cancel, so we can just multiply the real parts together. So -1 times -1 is 1. And then these imaginary parts, multiply them together. So negative square root of 5 times the square root of 5 is -5. And then I times I is I squared. All right, and then minus 5i squared is the same thing as plus 5, and that's just going to be 6. So the magical thing about it is when you multiply a number by its conjugate, it will always give you a real number. So you start off with two imaginary numbers that you're multiplying together, but you always end up with a real number, which is helpful in things we have to do later. All right, so let's look at B. For B, we have the square root of -90. So before we can figure out this conjugate, we do need to simplify this problem. So we would pull out the I and then simplify down the square root of 90. So we all know 9 divides evenly into 90, and the square root of 9 is 3. So this is going to be 3i square root of 10, or we could write it as 3 square root of 10i. So you guys take a second and write down what the conjugate of that is. All right, so remember, conjugates have the same real part. Well, the real part on this one is just 0, and they have opposite imaginary parts. So its conjugate is -3 square root of 10i. All right, so when we multiply these together, we're going to multiply -3 times -3. No, we're going to multiply +3 times -3. We're going to multiply we're going to multiply the square root of 10 times the square root of 10, which is just 10. And then we're going to multiply I times I, which is -I squared. All right, so that gives us, this gives us -9 times 10, and then basically times -1. So -9 times 10 times -1 is 90. Again, we started off with imaginary numbers. We ended up with a real number when we multiplied. All right, so your assignment is on page 152. So several problems. So 12, 14, 16, 24, 26, 30, 34, 40, 44, 46, 48, and 98. A lot of those don't take very long to do, so don't stress.